from where we are going to, where the water is going to flow and why the water is going to flow, you understood that. That means the concentration, it will flow in such a direction so that the concentration will become same. So if it flows from here to here, if it flows from the lower concentration to the higher concentration, you see, if the water goes from the lower concentration, then its concentration will increase. So from 5 it will become 6, from 6 it will become 7. And if the water comes over here, its concentration will decrease. From 10 it will become 9, from 9 it will become 8. One time will come when their concentration will be same. That means the C1 will be equal to C2. At that particular time, this will stop. This phenomenon of flow of water from the lower concentration to the higher concentration is called the osmosis. So what is osmosis? Let us define it. When two different solutions, simple words, two different solutions of different concentration are separated by a semi-permeable membrane, the solvent molecules flow from lower concentration region to the higher concentration region to attain the equilibrium. This phenomenon of flow of the solvent molecules to the semi-permeable membrane is called osmosis. Fine. Now what is osmotic pressure? What is osmotic pressure? See, it's also very simple. Now, the water is flowing in this direction, and suppose I am applying some external pressure from this side, in this side from the top. Now water is coming out with some pressure. Suppose I am applying the pressure 5 here. Still the water is coming from C2 to C1. I am increasing the pressure to 6. Still it is coming. I am increasing it to 7. As soon as I have increased it to 7, what I saw is that the water stopped flowing. Means we stopped the osmosis. How did we stop the osmosis? By some external pressure. Yes? That external pressure which is required to stop the osmosis, or I should say just stop the osmosis, is called the osmotic pressure. So what is osmotic pressure? It's the minimum pressure that is required to just stop the osmosis. It is the minimum external pressure required to just stop the osmosis, and that is what is known as osmotic pressure and is denoted by capital Pi. Osmotic pressure is denoted by capital Pi. Now suppose I have increased, I told that 7, suppose. Now I had increased the pressure to 10. Now what will happen? As I increased the pressure to 10, now the water molecules will start flowing in the reverse direction. In the reverse direction, it will start flowing from higher concentration to lower concentration. But certainly that is not a natural phenomenon. We are forcefully making it happen. This particular phenomenon is known as reverse osmosis. In general, we call it RO. You know, there are the water filters nowadays, RO water filters, which is actually the application of the reverse osmosis. So reverse osmosis. By reverse osmosis, actually we can desaline water. You know, in the coastal areas there is a scarcity of drinking water, but there is a huge amount of sea water. But obviously that is full of salt and there is scarcity of the drinking water. So what we do over there is we apply the reverse osmosis over there. The big plants are there where we take some amount of pure water. Pure water means the drinking water, and in the other side we had taken the sea-water. Obviously sea-water has got the concentration more. Now we apply the osmotic pressure, that means the pressure greater than the osmotic pressure with some external pressure, okay, which is greater than the osmotic pressure. Some pressure were greater than osmotic pressure. When we apply this, the water molecules, only the water molecules will flow over here. So you can collect the drinking water over here. The drinking water is collected over here. This particular phenomenon is known as the desalination of water. Desalination of water, and that is happening through the process or through the method called reverse osmosis. That is nothing but reverse osmosis. Now the osmotic pressure of a solution can be very nicely measured by an instrument called Pfeiffer's instrument, and the method is known as Pfeiffer's method. Okay. Now, the osmotic pressure of two different solutions, if we compare, then they are termed something. Suppose two different solutions are there, and we had measured the two different solutions osmotic pressure by Pfeiffer's method. That's actually out of the four methods, that is much easier method, that is the most easy method to measure. Okay. Now we had measured the two osmotic pressure of these two. Suppose this is pi 1 equal to 7 and pi 2 equal to 10. This is solution A and this is solution B. So we can say that the solution A has got osmotic pressure less than solution B. So we call solution A as hypotonic solution in comparison to solution B. Hypotonic solution in comparison to B. So what is hypotonic solution? The solution whose osmotic pressure is less than that of another one. Obviously this is a completely comparative value. That suppose tall. I am taller than somebody, but I am shorter than somebody. I am taller than somebody else with respect to someone, but I am shorter than somebody else, again with respect to someone. Now solution A is a hypotonic with respect to solution B. But if I take another solution C, whose osmotic pressure is 5, suppose pi 3 equal to 5. So in that case, A is not hypotonic. With comparison to C, this is called hypertonic. So what is hypertonic solution? Hypertonic solution is the solution whose osmotic pressure is greater than another solution with respect to another solution. Now if two different solutions has got the same osmotic pressure, suppose A has got 7, B also has got 7, both has got the osmotic pressure same, then we call them isotonic solution. So these three terms you must know: isotonic solution, hypotonic solution and hypertonic solution. These are all comparative terms. Means whenever the osmotic pressure value is compared with the other solution, then only we can use these terms, the hypotonic, hypertonic or isotonic. Now next is the mathematical part of the osmotic pressure, that how the osmotic pressure depends. A lot of solution was taken by a scientist called Van 't Hoff, and he did a lot of experiment with the osmotic pressure. He measured the osmotic pressure of a lot of solution, and finally he had come to the conclusion of two laws which are known as Van 't Hoff's law of osmotic pressure. What he found, the first one, that osmotic pressure of a solution is directly proportional to the concentration of it. Osmotic pressure of a solution is directly proportional to the concentration of the solution. More the concentration, more is the osmotic pressure. That's the first law, first Van 't Hoff law. The second Van 't Hoff law says that the osmotic pressure is directly proportional to the temperature of the solution in Kelvin. Okay, temperature in Kelvin. It is directly proportional to temperature in Kelvin. These are the two laws of Van 't Hoff law of osmotic pressure, which he found after performing a lot of experiments with a huge number of solutions. Now, if we just combine these two laws, what we are going to get? We are going to get pi is directly proportional to C into T when both are varying. So you can write pi is equal to some constant into C into T, and very surprisingly he found that that constant for the osmotic pressure is nothing but the ideal gas constant. So the equation he got is C R T. R is the ideal gas constant. Now what is C? C is concentration. In this case, but Van 't Hoff found that the concentration is nothing but molarity, not molality now. Now it is molarity. Now what is molarity? Molarity is number of moles of solute divided by volume of the solution in liter, we know it. So N2 divided by V into RT. So pi is equal to, we can write what? Pi is equal to, we can write N2 divided by V. N2 is what? W2 by M2 into V into RT. So that's the expression for what? That's the expression for the osmotic pressure, the fourth colligative property. So the expression for the osmotic pressure, the fourth colligative property, pi is equal to N2 RT, sorry, W2 RT divided by M2 into V. So these are the four different colligative properties and their mathematical expressions we have got. So what is colligative properties? Again, just in short, very short, I am recapping it. What is colligative properties? Colligative properties are the physical properties of some dilute solutions which depend on what? Which depend on the number of solute particles but not on their nature. They are of four types. The first one is relative lowering of vapor pressure. The Raoult's law expression for relative lowering of vapor pressure, we got this. The second one is elevation of boiling point. The elevation of a boiling point is also expressed by Raoult's law in this equation. That elevation of boiling point is directly proportional to molality, and finally we got this equation. Next one is depression of freezing point. Depression of freezing point means the freezing point is depressed of the solution, and how much it is depressed, that is also governed by Raoult's law, and this is the expression for this. And the fourth one is obviously osmotic pressure. What is osmotic pressure? Osmotic pressure is governed by the Van 't Hoff rule or Van 't Hoff laws, and osmotic pressure expression can be represented like this. So these are the four colligative properties we studied today. The next day we are going to start with the abnormal behavior of the solutions. Now these equations, whatever equations we had written for these equations, these are all used for the normal solutions. But whenever we do with certain other solutions, they show some abnormality. That is abnormal behavior of the solution, and we are going to study that next day along with the numericals related to this colligative properties. So today this much. Thank you.